Hello students, so in this video we'll discuss about electric field due to a dipole when it is placed in a uniform electric field, right? For your board purpose this topic is important, right? That means when a dipole is placed in a uniform electric field, we'll calculate the torque acting on a dipole when it is placed in a uniform electric field. Okay, see, let us say this is your uniform electric field. Uniform electric field means it should be parallel and equidistant. Okay, so now electric field is directed from, that means for a plus it is away and for a minus it is towards itself. So this will be plus, this will be minus. Okay, so this is a uniform electric field. And now I am placing a dipole in a uniform electric field this way. Dipole minus Q plus Q. This will be the dipole moment P. Let us say this as center of the dipole. Got it? So dipole is placed in a uniform electric field. Now let us discuss about the forces and the torque. Okay. See, positive charge will experience a force in the direction of electric field, of course, or you can say this is positive charge will be attracted towards the negative. So positive will experience a force Q into E. Negative charge will experience a force minus Q into in this direction. Got it? Clear? Force plus QE will be acting in the direction of electric field, or you can say towards the negative side, and minus Q will be downward direction towards the positive side. Okay, so this is the situation, students. Dipole is placed this way, a force from here and another force this way. That means two forces of same magnitude are acting but from different points, which will produce couple or which will produce torque. Clear? This you must have studied in your 11th class, that when two forces are acting from two different points, then they will produce torque, right? So a dipole will experience a torque. Torque is R cross F, and the direction of torque can be determined by right hand rule. Clear? So this is A, this is QE. So this is R, this is F. This is R, this is F. R cross F. Got it? Once again, this is your R, this is F. So torque will be R cross F. So torque will be coming out of the plane. Clear? It will be coming out of the plane. This way. Fine. So we have, okay, so this is A, this is A. Right? This is P, this is electric field, let the angle be theta. Theta is the angle between dipole moment and electric field. Got it, students? Okay, so now let us understand, one thing is clear, dipole will experience a torque, and that too in a perpendicular direction, perpendicular to the plane, or you can say coming outside of the plane. Okay, fine. So what will be the net force acting on a dipole? Net force acting on a dipole in a uniform electric field. For a positive charge, it will be plus QE. For a negative charge, it will be minus QE. Done. So the net force will be 0. Since two forces are of same magnitude and opposite direction, so net force will be 0. That means whenever you are placing a dipole in a uniform electric field, the net force acting on the dipole will be 0. This can be asked as 1 mark question. Clear? Got it. Okay. Now let us calculate torque acting on the dipole. Now according to the definition of torque magnitude wise is defined as force into perpendicular distance, right, from the reference point force into perpendicular distance. This is the definition of torque magnitude wise. Okay. So now let us find the perpendicular distance. Okay. This is force QE, right? This is A. Say students, this is A, this is theta. So this will be A cos theta and this will be A sin theta. Got it? This will be A cos theta. This will be A sin theta. Right? Once again, see, this is the situation. This is A. Okay. This is theta. So this will be A cos theta, A sin theta, and force is in this direction, this way, QE. Right? So what will be the perpendicular distance? A sin theta. Torque is defined as force into perpendicular distance. So this is the force. So this will be the perpendicular distance. Similarly, over this side also, A sin theta will be the perpendicular distance. Clear? So fine. Force is equals to QE into perpendicular distance. So actual perpendicular distance will be this much. A sin theta plus A sin theta. Right? So total distance will be 2A sin theta. Done? But now we already know that Q into 2A, that is charge into finite distance, that is termed as dipole moment. So magnitude wise torque will be PE sin theta. Right? Magnitude wise torque will be PE sin theta. In a vector form, torque can be written as P cross E. This is a torque acting on a dipole when it is placed in a uniform electric field. Clear? Force is 0, net force. Torque depends on angle. Torque depends on angle. So torque acting on a dipole may or may not be 0 as it depends on theta. Right? Suppose if the dipole is arranged parallel to electric field. If dipole is arranged parallel to electric field, then theta will be 0. So in such cases, torque will be 0. But what if dipole is placed this way? So then it will experience torque. Done? So torque acting on the dipole may or may not be 0. But net force acting on a dipole when placed in a uniform electric field, this should be noted. Right? If it is non-uniform electric field, then dipole will experience force also along with the torque. That is what we will discuss in the next or later videos. Clear students? Fine. So this is what torque is, when torque acting on a dipole is when it is placed in a uniform electric field. Got it? So now we will solve few questions. In the next video, we will solve few questions based on torque acting on a dipole. Thank you.